Next, we're going to talk about conditional probability. And so conditional probability, sometimes we know that one event has occurred. It can change the probability of the likelihood that another event occurs. So they are like dependent events. When we look at conditional probability and dependent events, what we need is kind of an example like this. So you have a selection of 6 balls, identical in every aspect except color. There are 3 green balls, 2 blue balls, and 1 red ball. You draw 2 balls at random from the collections without replacing the first ball before drawing the second. What's the probability that both balls are green? So if the events are dependent, then we must take into account the changes in the probability of one event caused by the occurrence of the other event. And so in this case, because we didn't replace the ball, we left it out. It depends upon basically what you drew for the first draw. Now you could also do, replace the ball as well and find some probabilities. So conditional really is read basically as the probability that event A will occur given that event B has occurred. So the notation for that is P, the probability of event A given B. That denotes the probability that event A will occur. So the first thing will occur given that B has already occurred. And again, in our statistics course, just for notation circumstances, remember that you have this probability of A, then there's a line between them, B. That means that you have the probability that event A will occur given that the event B has already occurred. So it's really important with conditional probability to make sure that you have your notation correct. Here's an example. So looking at a table, sometimes tables are easier to use than just looking at a situation. So we're going to look at a table first and talk about conditional probability. At a small liberal arts college, students have 3 housing options. They can live on campus, off campus, or at home with families. So the following table gives the number of students in each housing option by year in school. We can see at the very right-hand side, we have our total columns. So we can see that the total amount of students in this campus is 1,600. Okay, when we break it down further, we can see that the on-campus housing, there are 600 total students, freshmen, sophomores, juniors, and seniors. So the total column is on the very right-hand side, and the total column also goes across the bottom. So kind of separating them out by year and also by housing situation. Really important to take note of that when you're finding the probability of something. The first problem I have here states what's the probability that a randomly selected student is a senior who lives on campus. So I'm going to select from all the students, and I want to know the probability that I select a senior. So I'm going to go ahead and look at my senior column here, and I can see, doesn't matter if they're on campus, off campus, or home. I'm just wondering what's the probability that I'm going to draw a senior. Actually, I'm sorry, a senior who lives on campus. So we have to only look at the seniors that are on campus here. And in this particular case, there would be 150 of them out of the 1,600 that are living on campus. So the probability of a randomly selected student is a senior is 150 that live on campus out of 1,600. Okay, and then you would just simplify that down as a decimal, or you can leave it as a fraction. Again, kind of just depends on what the question is asking for or how you prefer to write it out. So this would be 0.09375. And then a conditional probability situation then would really mean breaking it down a little bit further. So the probability that what's the probability that they live on campus and are a senior? So we are kind of identifying the population here. Before, we were looking at the total population of the college and just the seniors that were on campus. In this conditional probability, you can notice here we've got the bar. So we're finding the probability that the student lives on campus given they're a senior. So the senior part has to happen first. And so when I look at that total number of seniors that are at this college, I can see that we have 425 of them. Okay, so they have to be a senior. And what's the probability from the senior class then? You're going to choose somebody that lives on campus. Well, we can see that again, there's 150 of them that live on campus of the 425 seniors. And if I divide that out, I get 0.39 or 3529. So what does that really mean? It really means that if we're to repeat this experiment of selecting a student at random, about 35% of the time, okay, this is a percent, about 35% of the selections that resulted in a senior being selected would also result in the selection of someone who lives on campus. Okay, so we're breaking it down further and further. Conditional probability. So you're given a situation and you need to find the probability of an event happening given something's already taken place. Let's go ahead and look at another one. GFI, ground fault interrupt switch, turns power to a system in the event of an electrical malfunction. A spa manufacturer currently has 25 spas in stock, each equipped with a single GFI switch. Suppose that two different companies supplied the switches and that some of the switches are defective, as summarized in the following table. So we have our totals again on the right side and across the bottom. I'm going to go to the next slide and we're going to answer a few questions, look at a few problems here. So we're going to identify the event E as the GFI switch in the selection spa is from company 1. Okay, so that's going to be event E, and event F we're going to say is the event that the GFI switch in the selected spa is defective. So we want to find the probability of event E. So basically what we're asking here is the probability of event E, I'm going to just write it out, was the switch is from company 1. Okay, so what's the probability that the switch is from company 1? And so we want to look at the whole company, right? And we can see that there are 15 switches that are from company 1 out of 25 total switches. That's going to give us the probability of us finding a switch that's from company 1. So 0.60. Okay, the probability of event F. So just writing it out, probability of event F. F is that the SPA, the GFI switch is defective. So I'm going to just put defective, just so we know exactly what we're looking for from the table. Okay, so I'm choosing that it's defective from all of the 25 that were looked at. And if I look at my defective column, I can see that there were 7 that were defective out of the 25. So that's 0.28. Now, I'm going to try to look at my table here too. We're going to kind of make a generalized statement about the formula for conditional probability. So let's just look from the table again because it's sometimes easier to see. The probability, I'm finding the probability that the GFI switch is from company 1. So company 1, and it is defective. Okay, so they have to have both of those conditions if this is an and statement here. And I can look at this, and I can look at company 1, and the number of defective switches is 5 out of the total number of switches that are there, 25. So the probability of coming from company 1 and being defective is 5 out of 25, or 0.20. And now I'm going to use this information to find the probability. So I'm going to write this out. Probability of E was from company 1, given that it's defective. That was our event F. So we can look at the defective switches. The number of defective switches was 7. And of those 7, we know that 5 of them were from company 1. So we're setting a condition here where we're only choosing from the defective switches, and then from there finding the probability that we choose company 1 from those defective switches. And that's 0.01. Or I'm sorry, 0.714. So that's larger than the unconditional probability of P of E. Choosing from company 1, because the company 1 has a much higher defective rate than company 2. So with that being said, we're going to kind of look at the generalized statement for conditional probability. If you have a table set up, sometimes it's easier just to go right to the table and pull the numbers down. Okay, but there's also a generalized statement or formula for finding the conditional probability of something. And this is the Venn diagram sort of the problem that we were just looking at, right? So event F was the switch being defective, and we knew there were a total of 7. Event E was the switches that were in company 1. If we go back, we know that company 1 had 15 switches, so there's 15 dots in here. But of those 15, we knew that 5 were defective. So there's 5 in the the intersection of defective and company 1. Here's the 5, okay, out of the 7 that are defective. But there's 5 out of 25 that are defective within that company 1. So this kind of is the visual. These dots out here then obviously are the ones that are not in that sample set. So we're looking back here and we're looking at our company 2 are outside of the intersection of those two circles. So it kind of just depends on what they're asking you to find. But we're going to go ahead and use that example and kind of look at the formula for finding the conditional probability. So if you're sort of a formula person, this might be helpful to you, those of you that like to go step by step. Some of you are going to visually be able to just look at the problem and see it. So sometimes that gets to be a struggle when we're in class, especially because some students will catch on much faster than others and not quite see it like others do. So we always can visualize it, but we also have a formula to sort of back that up. So the conditional probability of the event E, given that F has happened, is denoted by this. And the formula basically is the probability of E happening given F is the probability that the intersection happened divided by the probability of the given part. Okay, so let's look at another couple examples using that formula. And then from there, I'm going to have you do a worksheet and go ahead and email me pictures of your worksheet completed with your work on the paper Actually, I'm going to load something in Schoology, so you can submit it right there and take a